Okay, let me share my screen. Before we start, any doubt, anything you want to discuss before?
Yeah.
Okay,
So,
so yesterday we
hello.
have talked about Docker, Docker Compose, and today we are going to talk about Docker Swarm Cluster. Okay, so
Hello, Abhishek. I'm audible.
what is Docker Swarm Cluster? Okay, so first of all, let's understand the basics of Docker Swarm Cluster, and then I will explain you the other details step by step. Okay, so tell me one thing. This is your server. This is your application server 01, and you have three containers running. One, two, three. Application, database, and some other application related container. I would say A1. So by any, I'm not audible. Hello. One second. I'm audible now. Hello.
You are audible,
Hello.
but you cannot hear us. Can you hear us?
Now I can hear us. Now I can hear you. Sorry. Yeah.
Yeah.
Yeah. Tell
Yeah.
me.
So before
Mhm.
starting, I have a question.
Mhm.
Uh, like as a part of this module,
Mhm.
on
Mhm.
which module we are now?
We are basically on, oh, one second, let me tell you. We are on basically on the basics one. I'm going to send you Excel sheet also. Mostly
Okay.
when we have now what I'm doing, I'm not I have created the batch, but I have not segregated the people from the batch. So basically we are on the fundamentals of fundamentals of Postgre fundamentals. Yes, we are on the module one. Postgre fundamentals, installation on Linux, Windows, Docker and
Okay.
Kubernetes.
Okay.
Yeah.
Okay. Got it. Got it. Yeah, we can
But
continue.
I'm going
Nothing
to
else.
I'm going to send you the Excel sheet also where all the topics are mentioned and we can mark it, Mostly
Okay.
by next week you will see that also. Okay.
Mhm.
Okay.
Okay.
So let's suppose something happens to my server. In case if something happens to my server and my server is down, what will happen possibly? My entire production is down, right? Because all my containers are down, everything is down, right? So normally from the database point of view, let's suppose I have a database A. In case if I want to give high availability to database A, what we do normally, what is the common concept that we apply here? What are
So
the common concept?
we introduce high available solutions.
Okay, like
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 replication.
yeah,
very good.
application or patron clustering and all the things.
Replication and clustering. Okay, so basically replication and clustering. So what happens in replication?
So in replication, the data gets syncs from
Hmm,
the source to the replica server
mhm, mhm,
using like in case of MySQL, it is the bin log or the
mhm,
we can or GTID based replication we get kept. And in
mhm,
replication also we can have multiple strategies like master to master
mhm,
or chain replications
mhm,
or one source, multiple replicas. So
mhm.
those can be configured.
Very good. Okay. So in the same way, when uh, Docker Compose or Docker is not able to provide the high availability, by default, natively, they are not built to provide you high availability because they can just run one single container. In the same way, like replication and clustering, specifically, it is like clustering. We can create same service container or same kind of container in multiple nodes. Okay. When we do this, basically when we do this and we want to run the same service or same application container on multiple nodes, we can say it's a Docker swarm. Okay. And how it works? Basically, we have one master node, and we have worker nodes. Okay, so now understand like that we have master node and we have worker nodes. If you understand Swarm, gradually understanding Kubernetes will be also very easy. So now what is happening here? For same container, let's suppose my application is running application and my database. You can call it A1, A1. For the same application and database, I have two different containers also running on some other node. You can say these two are active and these two are passive. Okay. So in the Swarm cluster in Docker Swarm cluster, we configure containers on multiple nodes. Okay. And from the master node, we control them, schedule them, or control the states of all the containers. You can say this is my master node. I'm controlling the whole cluster from here. Okay. Likewise, you can add multiple other worker nodes also. Whatever worker nodes you need, you can add it and you can run your containers. Okay. So what is the advantage of Docker Swarm cluster? In case if my one node or my one container, I would say this is node, this is container. If my container goes down, automatically my next container will take the charge in within a second. Okay. If my database container goes down, automatically this live passive container is going to take the charge so that my applications are never ever going down. So that is nothing but Docker Swarm cluster. Okay. So here what I am doing, I am providing a high availability to my containers using Docker Swarm cluster. Okay. Docker Swarm cluster is just a, you can say Docker Swarm cluster is just a level 1 of Kubernetes. Okay. Is this clear at least high level? We have multiple nodes.
Yeah. So master node is having metadata.
Master node is having metadata. Master node is having the metadata, who's running what is the application and what it is holding. So this is primary and active and passive kind of configuration. Also, you can do load balancing level configuration also on Docker Swarm cluster. How is that? You can create your worker nodes, worker 1, worker 2, master node. You can also create a scenario. Let's suppose you have a lot of users. Let's suppose you got 1 million users. You can also say 50% of the traffic will be served by worker 1 and 50% will be served by worker 2. That is also possible. That kind of thing also we can do in the Docker Swarm cluster. So
You mean
whenever, yeah,
you mean both read only and write?
active. It can behave like active with certain percentage of the load.
Okay.
That is also possible. Even it gives you a lot of flexibility. Let's suppose you can say I want 50% distribution only for my application server. So 50% will work only for application from this node, and this node is going to run only database. Okay. Let me correct it. This is not correct. 1 second. Let me make it and then I will explain it. So let's suppose you have a scenario where you want to create 3 worker nodes and you want to say application 1, and DB. So you can even distribute like this, that worker 1 and 2 is only going to cater the application, and worker 3 is just dedicated for database. These kind of configuration can also be done on on Docker Swarm cluster. Yeah, Rohit, please tell me.
Yeah, it's an intermediate layer. So which is the intermediate layer which is redirecting? Load balancer is the intermediate layer.
No, load balancer is not intermediate layer. Master is just a controlling node. If you want to achieve any load balancing, you have to use your third party tool like HA proxy,
Okay.
HA proxy, or any other load balancing tool. Sorry, I have some issue with my pen today. HA proxy, or you can use keep alive D. All these things you can use. But by default, you can configure your container in a such a way so that it can achieve these kind of configuration.
So all the rules will be set up in this proxy, no?
Master
That,
node. No,
uh,
see, let me make a
Hmm.
picture like this, or let me get something from the internet.
So HAProxy and KeepAliveD is compatible with Docker too.
Correct. They are compatible with all these things. Whenever you have to do any kind of VIP or virtual IP, you can do that.
Yeah.
Let's see, this is the best picture I can explain you. I will put load balancer also here. Copy. Hello. I don't know why it is not getting copy. Let's copy this one. Or I will write my own. I will create my own better. So this is your application. It will go to your load balancer. In the load balancer, you are going to define the nodes or the rule. This is your swarm cluster. This is your master node. And this is your worker node, worker 1, worker 2, and worker 3. So basically, your application is going to hit your load balancer first. And then load balancer is going to, based on the node or based on the rule, right? Whatever rule you have set, it will route your traffic to the different worker nodes. Basically, it will go to worker 2, worker 3, like that. So basically, only clustering part will be managed by Docker Swarm cluster, and rest of the things you have to configure by your own. Yeah, David, tell me.
Yeah, a doubt. The thing is, in the cluster part is the load balancing is done by the master node. That I can understand. The but the data
No.
sync.
Let me correct you. Master node is just to control the swarm cluster, schedule the container, manage the container state, and
Okay.
it also provides the failover and switchover. It just holds the metadata.
Okay.
Yes.
Okay, and my question is, how the data synchronization is happening between the nodes? I mean, the Docker containers and the application A and one. Consider right if the load balance is redirecting the writing of write operation to node one and the read operation to node two. How the consider some write operation have been done in node one, that thing should be moved to node 2, right? How the synchronization is in
Okay.
the real time we used to
Yeah,
have
that,
that the log level it will happen, or in here how it's transferring the
basically
synchronization is.
here it is run over the services. Okay. So how it happens basically whenever I was not going into much depth because it is just an overview, but actually what happens, uh, just a minute, huh? So let's suppose this is your nodes, right? So under these nodes, what you do, first of all, while configuring any application, what you do, you create your services. Let's suppose this is finance service. I'm giving a name finance. So all the finance related uh, service related pods, containers are also called as pods. Okay. So these pods are running here. Pod 1, pod 2, pod 1, pod 2, something like that. Okay. And this entire synchronization is happening over the Docker level. Sorry, sorry, over the Docker level. So whatever, let's suppose this is my active and this is my passive. And basically in the outer world, I'm not bothered about whether it is worker one or worker two. Okay. I'm bothered about only for my service. Same like real application cluster. I will just hit to my finance service, and based on my configuration, let's take the rule number one. In the first rule, I have configured 50-50 rule, where I want to tell that 50% traffic will go to the node 1 and 50% traffic will go to the node 2, like that. First option. Second option, I can configure my services on active passive way, where all the active services are going to serve the traffic. In case active services are down, it will go to the passive service, like that. Again, in the passive service, I can define my passive service will be running from which node? Node 2, node 3, like that. While creating the service itself, I can decide all those things. Okay. And this communication is happening over the internet, over the network, over the intranet, over the using the services, whatever services you are creating. Okay. And if you go to very internally, you will find when you are creating Docker Swarm cluster and services, by default, like Docker. Let me show you practically. Just give me a second. One. So if you just do Docker ls network ls, okay, my Docker instance is not started. Let me start it. So my Docker is started. Now let me do. Can you see here the difference? Whenever I have started application, let's suppose this is my personal application which runs on my computer, my AIML application. Can you see a network bridge is already created for that service? This is also one of my network. When I use this application, my network is getting created. When I use the different application, the different network is getting created. So basically, internally Docker creates its own network, and it keeps all the services or pods under that particular network, and it gets communicated. This network can be isolated network, and this network can be bridge network also. When I say bridge, I mean anyone can join. If it is isolated, only two containers can talk to each other. Let's suppose container A and container B. Okay, like that you can create the entire cluster. Is this clear at least, David?
Yes, yes.
So basically, Docker Swarm cluster is the beginning or the initial or generation 1 cluster for Docker. Okay, and it has lot of issues basically. Okay, the first issue is speed. Let's suppose sometimes we have seen that if your network connectivity is not good, the Docker movement, the container movement from one node to another node happens little slow. Okay, second thing, uh, it it supports only service level of configuration, or it supports only pods. But let's suppose I want to add a domain to my service. Let's suppose I want to say www.fin.com, right? I want to add this domain to my pods. These kind of configurations are not available in the Docker Swarm cluster. Let's suppose I want to tell that I want to add this 50 GB of storage only to my Fin service. Okay, whenever the pods are coming up. So these kind of rule based configurations are not available in the Docker Swarm. Okay. Another thing, Docker Swarm scaling, the moment I scale my Docker Swarm to a certain level, it starts creating issues because it's an old framework. Okay, so to fix all these issues, to fix all the these kind of things, what happens? Google has introduced a new technology called Kubernetes. Okay, so Kubernetes is the advanced version of your Docker Swarm cluster. Okay, so basically, Kubernetes clusters are the cluster. First of all, it's an open source cluster. They are meant for auto deployment, scaling, management, and containerization orchestration framework. Basically, this is also container orchestration framework, but Kubernetes is also provides you an option to orchestrate your container applications. Okay. Another thing, let's suppose I want to create a API. Okay, and I want to deploy on the Docker Swarm. So I don't have much option to do that. But in the Kubernetes, I have multiple options to do the the configuration. Okay. So again, how Kubernetes works. Okay, I'm just giving you overview when we have Kubernetes class, because Docker Swarm we are not covering, but Kubernetes is covered by in this session. So basically in the Kubernetes cluster, again, we have control node. Okay, control node, and then we have worker nodes. Okay, same way here from the control node, I can schedule the jobs. I can execute any application. Application I'll come to know what I'm talking about. And basically my controlling node is also holding the metadata of my cluster. When I say metadata, basically it use etcd. When we will do the Petroni, we will also talk about etcd. What is the etcd? Basically etcd is a small database which captures all the cluster related information. So you can say it holds the cluster database. Okay, and the actual worker nodes are the nodes where your containers are running. Your containers are running like that. Okay, actual containers are running here. Also, we have a utility called kubelet. Okay, so kubelet related services are running on these all the worker nodes. Okay, so when we talk about the Kubernetes, Kubernetes is much more powerful framework than Docker Swarm cluster. Okay, we can do all the all kind of configurations in whatever we just talked about, right? All these load balancing, API, domain, and all those things. It can also be done here directly, and it is very straightforward. Okay, and Kubernetes have its own command line interface, which we call it kubelet. Okay, so basically here you can say your master process is running, and here all the agent related process runs. Okay, and using kubelet command, you are controlling your whole cluster. The entire Facebook, entire chat GPT, you just give me the name, I'll tell you they are running on Kubernetes or not. So 99.9% applications are running on Kubernetes. Most of the applications are running on Kubernetes. Okay, you can say Docker Swarm cluster is just a standard cluster, and Kubernetes is a enterprise grade cluster. Okay, and you can manage lot of things on top of Kubernetes. Even you can manage your application, database, network, services, API, lot of things. And also due to AI and ML, slowly in the market, AI and ML is also increasing, right? Your Kubernetes cluster can also control your GPUs. It can also be integrated with your GPUs. Okay, GPU part we will talk about when we will learn about AI and ML thing, why GPU is important, all those things. So this is a framework where orchestration framework which manages your entire container application environment. Is this clear at least? I have just given very high level overview. There are a lot of things in the Kubernetes like cluster, node, master or control node, worker node, pod, okay, services, namespace, like that. There are a lot of concepts we will learn when we will do the Kubernetes, but this is just a beginning. So I'm just giving you an overview. Is this clear at least?
Just a small idea.
Mhm.
Just a, you can say overview. Just a,
Correct. This is just an overview basically. And going forward, when we will do the Postgre on Kubernetes cluster, we will hands-on, we'll do all these hands-on on the directly on the cluster. Okay. And Kubernetes is important if you want to go to the next level database administration. Slowly, there are a lot of things happening on Kubernetes level. So this is important. If you want to understand all these things in detail, and you want to deploy your application and database, then it's very important because majority of the database and database related loads are getting deployed on Kubernetes nowadays. Okay, is this clear at least? From the overview point of view, basically we are covering this concept, the platforms for Postgre, so that when I am talking about all these things, at least you have some overview. So I have covered OS, container, Kubernetes. Now I'm going to talk about cloud and little bit part of the hardware. But at least now we are clear about container, Docker Compose, Kubernetes. Comparing with the older day, at least we have some concept. If I refer these technology, you will get some idea. If I talk about all these, you will get some idea. At least everyone. Okay. So now, as we are talking about the platforms, let's understand one more platform and then we will start doing the practice directly. Okay. So like Kubernetes, like Docker, Docker Swarm and all, we also have cloud. Okay. So basically what is cloud? Anyone? Can someone explain me what is cloud? What you understand about cloud? Anyone?
Like
What
it
is?
won't be proper. Like I would
Mhm,
say, like cloud is something wherein we have multiple physically we have multiple machines which are
mhm.
interconnected, but
Interconnected.
they seems to be a single server
Mhm,
to the end user, wherein there are multiple hypervisors running,
mhm, mhm,
which converts all the like suppose in example of EC2. EC2
mhm,
is nothing a VM, but
mhm,
we don't know exactly which machine it is running on. It is
mhm,
not
mhm,
on the upper layer. It is not shown, but
mhm,
internally there are multiple bare metal machines which
mhm,
are interconnected using hypervisors, and then
mhm.
on top of that we create our infrastructure.
Very good. So basically, uh, cloud is nothing but a combination of multiple uh, virtual infrastructure, and they, in other words, you can say they behave like a single unit, single logical unit. Whatever is running on your data center is is basically it's nothing but virtually we have combined, we have given a service name, and we have deployed in some area, you can say data center, and remotely we are accessing all the infrastructure, whether it is database, VM, network or anything, virtually we are accessing it. So there is another concept called platform as service. Okay, so before we understand the cloud, we have to understand some common concepts about these kind of technology. Otherwise, whenever I will refer these kind of words, you will not able to understand it. Okay, so let's understand this picture first of all. So on the left hand side, what what are services I have? I have network, I have storage, I have virtualization, OS, middleware, runtime, data, and application. Okay. What about infrastructure? Infrastructure as a service? Anyone? What about as infrastructure as a service?
So
What is happening?
Yeah,
infrastructure
so
Mhm,
yeah, go ahead please.
so this gives the infra as a service. Infra means like any infra
mhm,
you mean to say like the network infra or
mhm,
servers, storage,
mhm.
networking, those infra it will provide as a service.
Very good. So basically, uh, the blue part is managed by us, and the red part is managed by the vendor. Okay. So when we do these kind of setup, it is infrastructure as a service. Let's go a little bit ahead. Platform as a service. What is platform as a service? How it is little different than infrastructure as a service?
So in platform as a service, the maintenance part, OS
Mhm,
maintenance, all these things managed by
mhm.
uh, the service itself, like who is offering the service,
Very good.
AWS or Google Cloud. Yeah.
Very good. And that is called as a managed service also, right? The red part
Mhm.
is also called as a managed service. Okay. Tell me one thing. If I deploy these red part into my house, and I will give you the access to use it, what you will call it? Like cloud only,
Software
right?
is
So correct. Who said that? Let's suppose I have deployed it, and I have given you the access to the my application. In that case, it will called as a software as a service. If I am
Mm.
managing only a runtime till network, it is a platform as a service. If let's suppose I have given you access till the application data runtime and middleware, then it is infrastructure as a service. So based on the setup, based on the service offering, we have given a name. Let's suppose I have given you only access to the database. Which service it will be?
It will be platform
Database
as a
as
service.
service.
Database as a service. Very good. No, it will not be platform as a service. Why?
It's a software.
That's what that is that the confusion comes here. Now
Uh,
everyone is
uh,
getting it.
Yeah. So we
Okay.
generally call it as DBAS or something. Database
DBAS,
as a
database
service,
as
right? Yeah.
service, where I need only database platform and I am bothered about only data. I will take my backup. I will manage my parameters. I will do everything, but I'm not bothered about where my database is running, which network it is using, what is the operating system, what kind of network you are using. I am just bothered about my database version, database configuration, and database speed. When I say speed, CPU, RAM, and resources, right? That's what is happening on AWS RDS, right? Or Azure relational database, GCP relational database, or DigitalOcean, or anywhere, right? So basically, cloud is nothing but a combination of different services, right?
Abhishek, can we say infrastructure as a service EC2, platform as a
Correct.
service RDS, and what is
RDS.
software? Software as a service?
Platform as a service, you can't say RDS, you can say it's a
Okay.
database as a service. And
Okay.
software as a service, tell me what kind of categories we can put, what kind of softwares are software as a service? WhatsApp,
Yeah.
All
are we
applications on
Yeah.
managing?
Google Play.
We are just using it. We are not at all bothered about what other people are doing on WhatsApp. We are just using it. Tomorrow, and Gmail, right? Software as a service, right? I'm using just Gmail. I'm not bothered about anything, but I'm not paying for it. It's a free. But likewise, if I have other softwares where I'm just using it, I'm not doing anything. It's nothing but software as a service. Is this clear at least high level?
So
Because I'm
Abhishek,
going to, yeah, please
Abhishek,
start.
what is the example of platform as a service?
Platform as a service where, let's suppose you have code, you have data, but you don't want to take the headache of deployment. Let's suppose today we have decided that we are going to start a startup. Okay, I have idea, I have developed the application, but I don't want to buy servers, I don't want to do anything. So what I will do, I will simply go to AWS, put my credit card detail, I will connect my, let's suppose I am deploying my application on Kubernetes, I will simply go to EKS or Kubernetes service. AWS Kubernetes services. I will simply go to Kubernetes services. I will put my code simply there and I will start using it as a application. So that will fall under platform as a service because I have not created the platform, right? I have just given my code. I have given my data. Another configuration. Runtime, middleware, OS, virtualization, server, storage, network is not my tension or my headache. They are going to manage it.
Understood.
Makes sense?
Yeah.
But tell me one thing, if I am running a VM on AWS, in which category it will fall?
IAS.
Very good. This representation is little confusing, but it will fall under IS because I'm just taking the infrastructure from AWS and I'm going to deploy my application on top of it. Okay. So what is our layer? Which layer we all people are managing? We are managing data layer. Whenever I say data layer, think like I'm talking about this particular layer only. Data layer. Clear? Is this clear at least? On-premises, infrastructure as a service, platform as a service, and software as a service. Okay. So in the market, this is very important because this question has been asked multiple times from me. So cloud. So cloud is nothing but combination of all these services which we can access virtually, right? Make sense? Or which we can access logically from our house, from our network, from intranet, from network, all those things. Okay. One more thing, when I say intranet and internet, what is the difference? Intranet and internet. Because again, most of the time I'm talking about these words, right? Anyone? What is the difference between internet and intranet? So intranet is a publicly available network. Internet is publicly available network. Intranet is private network, which is accessed by certain people or certain group or certain applications. So whenever you go to a company and they have their own internal network, which will be called as a intranet. And if the network is widely available for everyone, it will called as a internet. Okay. So just whenever I am referring to these words, think like these concepts are, these words are, explanation of the word are like this. Okay. So cloud is a combination of all these kind of services: internet, intranet, storage, server, virtualization, OS, and all those things. Okay. Being a DBA, being a DBA, we are going to work on cloud on two factors or two services. Either our services will be going to deployed on VM or on managed service. Okay. VM or managed service. Okay. Is this clear? VM and managed service. When I say VM, what it means?
EC2.
When I say managed service, what it is?
RDS.
RDS,
EC2.
EK, EKS,
Sorry.
ECS. EC2 will not come here. EC2 will come under the VM. Okay. So from today onwards, clouds, we have two services, VM or managed service. Under that, these kind of services are there and we have to manage it. Okay. So some of the common concepts that we have to understand, and that I'm going to explain one by one. Managed service and VM. So first of all, what are the famous clouds are there? Whatever the market leader clouds are there? Anyone?
AWS, Google Cloud,
Okay.
Microsoft Azure.
Mhm. Whenever you want to see which particular services are, going good in the market, you can simply go to the Google and type Magic Quadrant from Gartner, and it always gives you the popularity of your cloud service provider. Okay. So currently, who are the leaders? Leaders are Amazon Web Service, Google, Microsoft, Oracle. Okay. We have other cloud service providers also like Alibaba, IBM, Huawei, and Transcend. Like that, we have other multiple service providers are also there, which normally companies are using, like Digital Ocean. Okay. Digital Ocean is also a cloud service provider. Inode is also a service provider. Okay. Inode.com. Okay. Same way we have Hostinger. Hostinger is also providing you some of the cloud services, not everything, but some of the cloud services. For database related, we have Heroku. Heroku Postgre provides you a database as a service for Postgre, and this is getting very famous. Okay, this provides you only database related cloud services. Okay, so these are some famous service providers for the cloud. Now let me let me remove the confusion and let me tell you. Hello, yeah, tell me.
Yeah, so sorry to disturb.
Mhm.
Like, Aurora service will comes under the MS. It is higher than managed service. Hello.
Hello,
Yeah,
can you
like
can you speak a bit louder? Actually, I was not able to hear you
yeah,
properly.
in managed service RDS,
Mm-hmm.
like we say, right?
Mm-hmm.
Aurora is there, right? Aurora will come managed service, or it is higher than. Any
No,
upper
this
layer
is
is there.
no. This will. You are absolutely right. It will come under the managed service. Whatever is software as a service or database as a service will fall under the managed service. And Azure is also managed service. Azure Postgre. So Azure database for Postgre. This is also a managed service.
I'm saying Aurora.
Oh, Aurora. I'm sorry. Aurora
Yeah.
will also fall under RDS. RDS Aurora is nothing but managed service.
Okay.
You're talking about this service, right?
Yes, this one.
So Aurora is also part of managed service. Clear,
Okay. Yeah. Okay.
everyone? So core concept, we have to go with these kind of core concepts, and we are going to talk about all these things one by one. So now confusion, which one should I learn? Okay, which one should I learn? So the deciding factor is based on three things. The first thing is, who is the market leader and who is getting used most of the time, who is offering most of the services. Okay, so if you ask with me like what should I do, I'm getting confused, should I learn AWS, should I learn Azure, my answer will be, if you know AWS, if you already know the AWS, try to learn Azure and then GCP. And if you know at least basics of these three, try to learn OCI. What is OCI? Oracle Cloud. Okay. If you are a database administrator, right after learning Azure, I will just prefer to use OCI. If you don't have any work on GCP, AWS, Azure, and OCI. Now, few people will ask like question, why OCI? Why after Azure OCI? Why not GCP? Okay. So again, it will depend on the use cases, but if you are an Oracle database administrator, and if you are from the Oracle side, lot of managed services are provided by OCI. Okay. And there are a lot of good career options are available on OCI. In the same way, after AWS, Azure services are picking up in the market. They are providing a lot of good services. Okay, so some of the companies who are not using AWS services and they are using all the Microsoft related products, they prefer to go to Azure. Okay, and a lot of these certifications are free. Okay, you can go and get the certification, at least level 1 certification free of cost from their website. Okay, makes sense? Okay, is this clear at least? Which one should I learn? So these are the four options that you can think of, and based on your requirement, based on your compatibility, you can choose. But my first preference is these two. First, second, either this or either this, you can choose. Okay. But if you are from the database side and if you are Oracle DBA, try to learn this one. If you are an open source DBA and you are doing a lot of analytical thing or big queries and all, you can also choose, also learn GCP. Okay, but these four are going popular in the market, and from the database point of view, most of the services are getting offered by these four service providers. Make sense? Everyone, just at least one vote, just to confirm that I'm not talking to myself.
Yeah, that's
Okay, so let's take a quick break and we'll be back in another 10 minutes. Today we'll take 10-minute break because we have some practicals also to cover, and then we will go ahead. Okay, so let's back by in another 10 minutes. Make sense? It's fine with everyone? 10 minutes.
yeah.
Yeah.
So I'm stopping the recording once we are back, just remind me about the recording. Okay.
Hello, sir.